So for my very first test gear teardown, we have the Data Precision 945. It's a 4.5 digit liquid crystal display LCD multimeter. I just got this in the post today. It arrived from eBay, £5, doesn't work. The vendor told me that somebody spilt coffee into it in 1983. They couldn't fix it then, and so 35 years later it shows up on eBay as a thing to be repaired. So let's take a look at what we get. The meter itself, obviously, but the kit has these side push buttons for range selection and function selection to go into the various functional modes. This is quite a common feature of meters of this era. It all got started with the Fluke, and I can show you an example of a Fluke. This is an 8060. Has the side push buttons for range and mode selection, and everybody copied that idea, and we have things like the British Avo DA211 also has the side push buttons. These are selecting ranges, and these top ones select modes. Quite a common feature. I just want to take apart another day. Okay, so what did I get for my £5 well spent? Well, I got the meter and I got a manual. There is the manual for the Model 945, printed in 1981, I believe. Where's the date in this thing? There it is, 1981. And in the back we've got not just a schematic, but a fold-out schematic. Look at that. So this is fold-out schematic. There's the display, there's the main chip, all the circuitry, and elsewhere in the manual there's a physical layout of where the parts go. There it is, so we can locate components, and there's a full description of how the circuit works and how to calibrate it. Very, very nice. Don't get that anymore. So that, I think, was a good thing to have. The name Data Precision, this is the Model 945, not a name that you'll see anymore, I don't think. There's some connection with a company called Analogic. Don't know what happened to them. If anyone knows what happened to Data Precision, do let me know, because I've got a few meters by them. Here's one. Another meter to tear down another day, but this is the Model 245, again 4.5 digit. This one's got a dial for what you want to measure and a dial for how much of it you want to measure. This is Panoplex, so these are very lovely little orange neon displays. One to take apart another day. So, what have we got in the 945? If we take the back off, this must be for getting the battery out. I'll take that off. Yep, there's a back cover there. There's a little slot there for putting the spare fuse in. That's missing. The battery fits in this space here. The battery clip there. This thing looks like, yeah, there's a shield, caution and warning messages there. A shield for screening the rear of the circuit board electrically. Some screws which are going to have to come out. And we've also got some adjustments all over this thing for calibration. So we've got resistors here and here. There's a capacitor down there for trimming out the AC ranges. Let's just get this out of the way. That's going to have to pass through there. The battery clip. So there's the screen. A couple of quite long screws in the back of that. So that out of the way. Now we can see some of the printed circuit board. And sure enough, we've got that big chip which we saw in the schematic. We've got the adjustments. We've got a fairly big PCB there. And a second PCB a bit further down, and there must be, yeah, there's some screws there holding it together. Looks like we're going to have to get the other screws out. So there's some more screws down there. There's screws at the bottom here with little nylon washers under them for insulation. Okay, that one's going to stick to my screwdriver. Oh, where did it go? There we go, and the washer. And the other one, come on, doesn't quite want to let go. Is that gonna, there it goes. There's the 2 screws and washers, and up the top here, look, there's 2 more screws. There's a screw there. These look like they're either side of the display. That's on the other side of this board at this level. 2 little short self-tappers there. Just get those out. Being very careful with this because we just don't know how delicate the plastic is, whether there's a bit of brittle plastic somewhere that we might break. So don't want to break it, and it doesn't want to shift. Doesn't want to go. Don't want to pull too hard on that, because there may be more screws hidden away that I can't see, and I can't see any. Okay. I wonder if you have to take all of these screws out. That would be inconvenient. Start in the middle. It's the wrong size screwdriver. It does not want to go. Are they actually holding it into the case, or are they merely holding the 2 boards together? Why doesn't that want to let go? I really don't want to force this because I don't want to break stuff. We can see some precision resistors in here. There's obviously some good things going on. We don't want to break stuff by trying to get it apart in a hurry. So if I can't figure it out, I may have to do this in 2 goes. Now that's okay. It's a little short screw there. These are not wanting to shift. Oh, those are on the back of the... those 3 screws are on the back of the terminals. Maybe they do have to go. They're just quite tight, and I don't want to break something. There we go. Okay, are they the same size? Yeah. Okay. There it goes. There it goes. We may find that these are simply holding the whole thing down, and they're also what makes the contact between the board, that was tight, and the terminals. Does that want to let go? Oh, that does want to let go. Yeah, that's really letting go. There's a connector. Okay, so down here, this row of pins here is a connector, I think. So let's give that a gentle tug. Yes, there we go. So that's come off quite nicely. So there is our board. Just looking for any signs of a date code on that, but I can't see any. Aha! Oh, look at this. Good precision stuff in here. Good analog things. Oh dear. Not sure I like that. What we've got here, these little holes here, are actually connectors. And they're making contact with what drew my attention to it was these pins sticking up from these switches. So they're using the pins of the switches to make contact with these connectors, so when you put the thing together, it actually connects these to those. And then there's the row of pins down the side, which really is a connector. Yeah. Oh, yeah, not sure about that. Not sure that's a brilliantly good idea, but alright, there's one of the boards. You can see we are making contact down the bottom here with the terminals on the outside of the meter. There is the connector that mates with the pins on the main board. Big carbon resistor there. Little white precision resistor network there. Interesting. Yeah. Oh, don't drop that. Excellent. Okay, what else have we got? Well, there's the main board of the meter. Over here we've got the input terminals, the range switches with the buttons on the side, and some pins down here that connect to the other smaller board. all of these pins here are part of the switches, and you can see some of them just stick up a little bit further and they connect to the daughter board. Well, does that board come out of the case then? Have we taken enough of it apart to actually remove the whole thing from the case? I don't know quite what to grab hold of and pull on this. Well, that came off. What's that? That's one of the terminals. Interesting. Yeah, that's in two halves for some reason. What else have we got? Now, ooh. Now the board's still held down by something, so what is holding that board down in that case now? Can I spot what's holding that board down in that case? Is it this? And is that a size I've got a nut driver for? Oh. Let's see what happens if I just loosen off that spacer. Okay, it comes off. Fantastic, a spacer. Oh, bit of movement there. Have I got to unscrew these from the case? No, I haven't. Right, okay, so it's all coming out now. So hopefully you can see that. So the whole board is now coming out and tilting just a little bit. Come on. There's something getting caught. Something is not quite wanting to let go yet. Get maybe the push buttons. What's holding that? There it goes. There it goes. Just a little bit caught there. So okay, there is the meter main board, and I think there's a screen. Yes, another screening cover on this. So they were concerned about electrical interference, keeping external electrical interference out. So there's a screen there which must be grounded, and there's the rather sorry looking liquid crystal display, which I can catch the light with that and I can see it's got the segments of the 4.5 digit display. There's some elastomeric connectors in there which look a little bit not very good, but it shouldn't be transparent. There should be a grey backing or silver backing on that, which has almost entirely disappeared. Don't know why that is. And I can see that I think I have undone the wrong screws, because this should have remained part of that. That should have remained on there. So when you come to take your Data Precision 945 apart, don't take these two screws out, because these two screws don't hold the board in, they hold that cover over the LCD. I'll put those back in, I think, but let's look at the rest of it first of all. There's the inside of the front cover. That's the little thing that actually holds the main PCB down. And the window for the LCD, the hole for the buttons. And there's an interesting thing here. That is another cutout for a switch. So there's the cutout for the power switch, another cutout for a switch, but the label covers it. So I wonder what that was for. Some option or afterthought, or a change of design, or maybe a different model that has an extra switch there for some other feature that this one doesn't have. That I will take to the sink at some point and scrub, because it's quite dirty. I'll scrub that one clean. One thing to notice on here, if I can get that a bit closer without it going out of focus, 20 megohm. Fantastic. It's got quite a high ohms range there. 100 nanoamp. It looks like each resistance range has got a current underneath it. I reckon that's the amount of current that the meter puts through the resistor to measure it. So it puts a milliamp through a resistor of up to 2K, but a resistor of 20 megohms only takes 100 nanoamps to measure it. Never seen that on a meter before. Okay, so that's to be cleaned. This, I think we're going to have to clean the buttons. Quite apart from any other repair I'm going to do. There's the power switch, looking a little bit shabby. Now, date codes. What have we got? Can we see any date codes in this that will give us a clue as to how old it is? Well, yes, on that chip there, the ICL 7135 by Intersil, 8201. So that's first week 1982. What else have we got? The 7555, 8137. That's, again, 1981. 8122 up here on the display controller. Looks like 81 for most of it, 82, very early 82 for the other one. So definitely early 80s. There are the two Caddock, hopefully that can get a bit closer, two Caddock resistor networks. These are high precision ceramic substrate resistor networks, commonly seen in meters like this. Fluke used them a lot. No surprise to see those in there. Well, I think that's about torn down as far as I want to go for the moment. Main board there, daughter board there. Any date codes on that one? Most likely the same. Wouldn't be surprised that they're all much the same. There's a little metal canned diode or transistor there. That could be the voltage reference, the master voltage reference for the whole instrument. There's an ICL. Now this is another part which is common to Fluke meters. This is the ICL 7660, which is a negative power supply generator. So this is a little oscillator, some diodes there and some capacitors. This will oscillate and generate a negative power rail. Quite a common thing to see in things like this. I think the Fluke 8060 has one of those. Couldn't tell you why there's a dirty great carbon resistor in here. Maybe there's a reason for that. Well, I think it's fair to say there's a reason for all this stuff. I just don't know what it is. Some tantalum capacitors, always suspicious of those for going short. They tend to be a problem. No sign so far of that coffee incident from 1983. Now, thinking about it, if someone, in that email that the vendor sent me, if someone spilt coffee in this in 1983, and that date code 1982, it was only less than a year old when he did that, so it must have been quite annoying at the time to have a really rather nice meter, about a year old, and you spill coffee in it and it doesn't work anymore. Wish I could see an obvious sign of damage, but I really can't see anything. It is absolutely pristine in here. There's no sign at all of any of that coffee. But of course it could be underneath the switches, it could be in the switches, we just don't know. It could be anywhere. As I say, I think that's as far as I want to go tearing this down for the moment. Next step, of course, is to repair. And I'll make another video if and when I get it working, and we'll have to do something with that display because that's a completely separate problem. That isn't the coffee that's done that. That, I think, is sunlight has affected the backing of the LCD. So it may have been stored somewhere sunny for 35 odd years before I got hold of it. Anyway, there we have it, the Data Precision 945. If anyone knows what happened to Data Precision, do let me know. Meanwhile, I will go ahead and see what I can do to mend this and make another video once I have it working.